Hello and welcome to this tutorial on making graphs with Google Sheets. Obviously the first thing that you'll need to do when making a graph or a chart in Google Sheets is have some data. So I have created a data table in front of us. This is the data table for an experiment where we took a pop can, it had some initial volume of water in it that we varied, and then we let it run for 30 seconds with a hole of 7/64 in the bottom. And then at the end we measured how much water had drained from the can. So you can see this is my independent variable, the initial volume of water in the can, and then I changed it by 15 milliliters every time, 60, 75, etc. Just as a recap, you can see these are the characteristics of a good graph or of a well-made data table. It has a title, the columns all have headings and units. The independent variable is, since this is what I changed, is in the first column, and then I collected my dependent variable data here. I've done 3 trials for this experiment, so then obviously I'm going to need to average all these together. So you could do this with a calculator, but a nice little trick if you're not familiar with this is you can make Google Sheets and other Excel and other spreadsheet programs do formulas that will do this for you. So you get to them by just hitting equal, and I'm going to use average again, but if you just start typing, so if I type A, here are many of them. I could have it added, and it gives you a brief synopsis, but if I type AVE, there's average. I want to take the average, and then it asks me what cells, put the cells in parentheses that I want to take the average of. Well, I want to average these 3 data points for 60 milliliters of water. Close the parentheses, hit enter, and it's done the calculation for me. And what's really nice about this is once you've done one, since I want that calculation 4 more times, if I click the cell and then hold and drag down, it'll carry that formula over for me. So it's done all the work for me. It's faster than putting all these numbers into your calculator. But you don't have to do it that way. So now we're going to insert a chart. So we're going to go insert, chart. Now you may have seen or may do it where you select all the data and then click insert chart. I like to do it this way just because depending on what words or columns you grab or don't grab or highlight, sometimes Sheets in Excel have a weird way of putting together your graph, so I can just start from scratch this way. So the very first thing that we are going to do is change the chart type. So in this class, unless you're told otherwise, you're almost always going to use a scatter plot, but there may be some scenarios where we do some different types of graphs. So I'm going to change chart type to scatter, and then it's going to the next thing I want to do is select what data will go on my y-axis, or what will be my series of data. So I can highlight the data instead of typing in the cell, so I'm going to grab this graph out of the way. I know my series is going to be the averages, or my dependent variable. So if I come over here, select series, it asks me what data do I want. I want these data points. Click OK. And now if I look at my graph, you can see it's put them in there, but I need to tell them how to space it. There's nothing on the x-axis. So on the x-axis, that's going to be my independent variable unless told otherwise. So that's the initial volume of water. I do the same thing. What data do I want to collect? Click OK, and now it's put it in there, and now it has spaced it sort of appropriately, and we'll come back to that in a second. So now that I have my data in, I've got a general graph as we saw, but I need to add a whole lot to it. There's no title, there's no axis label, so now we need to do all that. We started here, it starts you off at data. I've just selected customize, and now I can get all these options. So we've already done chart style, so we're going to do chart axis and titles. And when you click type, it asks you what, so chart title. A couple ways you can do this. You can just type this in. You can also come back over here to what you've already set up in your data table. If you've made it a good title, then you can just select and Control C to copy, come back into your graph or chart where you were, and now Control V to paste, and it's put it in there for you. So we now have a chart title. You can do the same thing. The horizontal axis is going to be our independent variable. So we're going to put on a horizontal axis that I can type it in, initial volume of water, or I can come back over here, Control C, Control V. And then lastly, I need something on the vertical axis. One more time, Control. I don't actually want all this, I just want the title, so Control C, edit, chart, customize, Control V, volume of water drained, and really in milliliters, this is the average volume drained. Okay, so now that I'm done with that, I can get rid of that. In series, we need to add a trend line. So let me click over here. We need to add a trend line to this graph so that we can start to get an equation and figure out what type of graph this actually is. So under series, there's an option to add a trend line. When we do that, we can see it puts in a line, but we need to know some specifics about that. So if we scroll down, we can have it label the graph. It's going to label the graph with whatever we want. So custom, but we're gonna always use an equation. So here's the equation for the graph. It always, since this is a linear type of trend line, it's always gonna put the equation in y equals mx plus b. And we wanna know how reliable our line of best fit is, so we're gonna show the r square, and since r square has a value of very close to 1, we're gonna assume that that's a pretty good line of best fit. So now that I have a trend line in there, I can get rid of that. There's nothing, if you want to change the legend color or whatever, you can, but there's nothing we have to do. For the horizontal axis, so depending on how you select your data and put this in here, this is really important. You need to make sure that this box right here, treat labels as text, is not checked. Again, is not checked. If you look at this equation, you can see right now our slope is 0.643. If I check that box, and sometimes Google will default and check it depending on what you pick, you can see it changes my slope to 11.8. That is a very different slope and y-intercept as well, because it's now not treating these as numbers, it's treating them as words, and it just spaces everything evenly. So that's not what we want. So we need to make sure treat label as text is unchecked. The other problem that I have with the horizontal axis is that it starts at 60. We need our origin to be 0, 0, so we have some idea of scale here as well. So if you scroll down, it asks you what the minimum value is. Right now it's 60. If we just put in 0, you can see it updates the graph, and now my origin is 0. So that's it for the horizontal axis. We would do the same thing for the vertical axis. Make sure treat labels as text is not checked. Now in this case it has put 0 as our minimum y value, so we're okay there, but if we needed to, we could assign it to 0 as well. And then grid lines, there's absolutely nothing to do. So this is our chart. One thing to do to make these a lot easier to read is if you right click on it, on the options button, you can move to its own sheet. And now I have a whole sheet here where I can see everything. I can see my data. I can see it meets all the criteria of a good graph. It's got a title. It is a scatter plot, which is appropriate for this data. The label, there are axis labels with units. The origin is 0, 0. There's a line of best fit with the equation shown and the r square valued. And since this is a straight line, we know that there must be a linear relationship. So in other words, what I can conclude is, as I increase how much water is in the can, the amount of water that is drained from it in 30 seconds increases as well. So it looks like when I have more water in the can, more is going to come out. So how much the flow rate changes. So just to recap, at this point you should be able to take data that you collect from an investigation and create a graphical model from it, and then use that graphical model to develop a mathematical model. Now, if this weren't linear, which we will encounter throughout the year, there's some additional steps that we'll need to take, but that will come at a later time.